To getting started building generative AI applications, chat, search, and image applications. So we're going to look at in today's workshop really what are the gotchas or what are the important parts you want to think about when building these type of applications. And we're going to do that right after this quick introduction. Welcome back, everybody. I hope I did not lose anyone in that introduction, but if so, then you missed the whole point. This is the real fun part. So I put a little question into the audience there just to see what's everyone's experience level building generative AI applications. I imagine we have quite a different level, or at least a little diverse group of people in terms of maybe you built something before, maybe you deployed something. So I'd like to know exactly, which everyone's experience level is, and also where you're joining from. I'm joining from a very snowy Stockholm. This is the season for it to be as far as regards to snow and staying indoors all the time and darkness. So maybe you're coming from a bit of a maybe a warmer climate. So someone tell me the temperature where you are. Hopefully it's warmer than where I am. Okay, cool. Let's see. Fernando, no experience. Nice. Okay. RJ, Seattle. I don't know what's the temperature like in Seattle. I imagine it's the same. Seattle is obviously our headquarters in Microsoft, so I should know better. Cool. Remya, no experience as well. Patrick, you already know what we're doing. So drenching in snow, yes, of course. And no experience for Wadid. And it's extremely cold in Seattle. Okay, that's good. There's going to be someone that's going to be like, I don't know, in like, I don't know, 30 degrees or something. Cool. No experience. Love it. Okay, Lucy, it's got to be kind of warmer in Texas, I would imagine. And I have experience using Azure OpenAI. Thank you, JM. That's about it. Also from Orlando. I think Orlando is got to be a little bit warm too. Warmer than here. Yeah, Faye. Cold in NYC. Yeah, we're all experiences. Cool. Love it. Love all the chats. Keep it going. This will be a session where you're allowed to ask as many questions as you like. There's no limit. And again, I want it to be kind of, again, since it seems like a lot of people don't have any experience, hopefully a good foundation for building these type of applications. I think there's a lot of terms out there, there's a lot of tools, and there's a lot of techniques. And that's what these sessions are really kind of being about. So let me go ahead and put my little head down so you can like see the content more. Maybe you're not here for me. You're here for the content. Cool. So welcome to getting started building generative AI applications, chat, search, and image apps. So I guess the start of this, when I built this and I named this session, I thought I could cover all of these things in about 45 minutes. I made this presentation, and you know what? I just don't think I'm going to get to image applications. And I think it's a discredit to image applications. Maybe you're here only to learn about image applications, and for that, I am truly sorry. But we will cover chat and search applications, and we actually have a session next week where I'm going to talk about functions, but I'm actually going to include the image application side of them. So if you are only here for image applications, I'm very sorry, and you could put your disappointment in the chat. Yes, I am very sorry, but this is what we're gonna do. We're gonna cover these types of applications. I think they go along, they suit yourself very well, and yeah, I think this is gonna be a good session. So let's get started. So this is going to be following along our kind of a bit of a trailer to our generative AI for beginners curriculum. I don't know, has anyone seen that curriculum? Let me know in the chat. It's a free sort of GitHub curriculum, and you can basically go to this link here, aka.ms Gen AI beginners. I'm trying to get into my chat window, but I can't. And now I've got you stuck. Oh, here we go. Let me go ahead and type that into the chat, aka ms Gen. Don't don't talk and type, people. This is dangerous. I hope that's it. Perfect. But yeah, this is completely free. It does at the moment require you to have access to Azure OpenAI, but we actually are translating this using OpenAI as well. So that hopefully by early next year, we'll have that to you. But it also covers some of the good concepts as well, which I think, again, if you're getting started, you want to get a good foundation before you jump into maybe building your production application. Cool. Another thing is, so all these resources I'm going to send to you or share with you will go be on this page. This aka.ms/links Gen AI. I think Erica's still in the audience. Erica, if you could do me a favor and put that in the chat. Wow, look at that, everyone. That was quick. Erica's in our background helping me produce this workshop thingy, and she's got the link already there, ready to go. So I appreciate you, Erica. Perfect. So that's going to be where you'll see a couple of things. You're going to see the link to the course I just mentioned. You'll also see a link to a Discord. So we're building out a community of everyone just kind of learning and trying to build out generative AI applications. So you'll see that as well. And then a collection of other resources that you can learn and start building this stuff. But that's enough of the sort of commercial break. Let's get into some of the content. Yeah, so this is part of a series, last bit. I just did this one last week, and it's talking about the foundation. So if this is your first time looking at generative AI, I do recommend it on this channel, going to that, because that's where I kind of covered some of the foundations, prompting, which is super important even for any type of application, and exploring the different type of large language models out there, open source, proprietary, all these options out there. So helping you kind of make the decision, giving you some pointers at least on that. Cool. So building with LLMs, that's what we'll skip. We covered last time. Today we're going to look at 3 application types, but like I said, 2, which is chats, which is generally around like question and answering, and I think that's a lot. Chatting or chat applications have brought a lot of focus, with ChatGPT and things like that, and everyone wants to emulate that experience in some type of way. So we'll look at how that's possible, and then we're also going to look at search. How using techniques like semantic search that we can make better search applications than we've seen before, and also giving context and information to our users or customers or whatnot that is going to be super relevant to their focus. So chat applications. So the first thing that I think about chat applications being working in AI for some time is chatbots. Chatbots was all over the rage. Let me know in the chat if you've ever. Let me know in the chat. Let me know in the chat if you ever use a chatbot, and let me know how your experience was with that. And this is not trashing on chatbots at all, but chatbots, they are really great. They are primarily kind of a rule based in some cases, but they're not necessarily. They're different chat applications, right? They're not necessarily using a generative AI model in the background, and maybe we can do some grounding and some dynamic kind of working with those chatbots. But again, it's not necessarily the experience that we get from ChatGPT, right? And maybe that's really what you want when you're building your application. So that's kind of the difference, but we're going to look at a couple of different areas. One is the system message, and then prompt templates to really kind of design a better user experience. And then lastly, model selection. So there's actually quite a lot of different models out there for guiding or developing a chat experience. So let's look at what's available for us. So in terms of system message, so when you're using even ChatGPT or any type of chat application that uses a generative AI model or a large language model, it typically uses this concept called system message. And a system message is kind of like the role playing of the model. If you don't have a system message, then the model is essentially going to operate in a way that it's sort of trained on. But normally with a system, which could be okay, but normally with a system message, when we're building applications, and this is what the session is about. We really want it to be tailored to our scenario or our use case that we're building this application for. So the system message allows us to sort of guide the model in a way to give it direction. So if you think of the model as like the actor, you're the director of that in a way, where you can kind of give it some guidance so that the type of responses or the type of answers it gets is in line with your use case or in line with your user expectations. And so in this case, I'm going to break down a system message just to show you like the level of detail that's kind of needed to design a really good one. Because it's not just, be a helpful assistant and, give good answers. Like it could be like that could just be it if you want. But if you really want a targeted approach, you need to take a tiered approach to the system message. So in this case, and I hope it's kind of clear on your screen here, we have the system message that I pulled from one of our open repos. And essentially, this assistant is trying to be a guidance to answering questions about the company's health insurance plan. So the beginning of the system message is kind of defining that role or that character, which is saying you're an assistant that helps the company employees answer healthcare questions and answer questions and employ with the employee handbook and be brief in your answers. And that's like a little nuance that maybe some people kind of miss out when they design this. Like you can also kind of give it an understanding of what type of responses or length or the type of answers that you want the users to have, right? So in this case, right, when people are going to this assistant, they want quick answers, right? They want, oh, is this covered? Like, is this covered in my health insurance, or what type of coverage do I have? So if we give the model some guidance there to give it very brief answers, then it's going to really give the user's expectation of the type of answers, which is going to be a better model that way. So we got a question. Let's see. Is there a way to do prompt engineering in the Azure OpenAI Studio, or does it have to be in the Python SDK? More so, is the system message the only prompt like engineering you can do in the studio? So the Azure Studio, for anyone that doesn't know, it's more of a sort of graphical interface to both helping kind of deploy the models, but also, to answer your question, it has a playground where you can actually do your prompt engineering. Most of the time, and we wanted to do system message, for example, that's normally done in the code. So when you're defining the model, you can also include the system message there when you're pulling the model in, and this is where that conversation or that prompt would be in. But yes, you certainly can do prompt engineering in the Azure OpenAI Studio. It's just using the playground. But great question, JM. So going back to our presentation here, and my mouse is like, I'm getting lost in the mouse because I got my screen in the wrong areas. So the next tier, right? This is just still part of the one system message, is that we're now also saying answer only with facts listed in the sources below. So in this case, we're going to have a resources place, whether that be a database or some documents. But we're now guiding the model to say answer only in the facts that are listed in these sources. So then that makes also the model not simply like, oh, well, I can't find the answer here, so let me go to all of the data that I've been trained on, essentially, and find an answer. So in this case, when we want, basically the model will say when it can't find an answer, it says, I can't find this answer because I'm only pointing to the sources below. And then we give the model basically an out, or basically a way to say, hey, I don't know, which is completely okay in this scenario, right? So if there's not enough information below, say you don't know. Don't go looking for it on the internet or something like that, right? So kind of like a job interview, if you will. Like if you don't know, don't just make something up. Just say you don't know, because maybe that's actually better than saying something that's wrong. And then so do not generate answers that don't use the sources below. So again, this is kind of even showing you the level of detail that you will need to do in some cases to make sure that the model does not respond with answers. So it's kind of giving you like we gotta get three limitations here, right? So if the answer below doesn't say you don't know, answer only with the facts listed in the sources below, and do not generate answers that don't use the sources below. So we have like 3 layers of do not or do kind of things, right? And in the world of prompt engineering, like these, like being more positive, if you will, like answer only instead of don't answer, is seen to be more effective. But answer only at the beginning is a good thing. And then even though we do have a do not here, it's kind of the third level of that. So again, this is giving the model, just to give you more context again, with the system message, giving the model the limitations or guidelines that we want. And then if asking a clarifying question to the user, so sometimes the model responds clear, that user that would help. So we're going to give it the model a chance to ask questions to the user. Go ahead and ask the question. So again, this is driving even more of a chat-like experience because now that you're kind of having this two-way conversation with the model, not just saying, is this covered in my health insurance? And then the model says yes, no, and or maybe giving out references. So it's also giving the model an opportunity to generate clarifying questions. Now it's kind of the third tier of the system message, which is, I like to call like more of a delivery side of things. So we might want to design a way because we have different data that we want the format to make sense to the user, right? To see it in a good way where they can sort of interpret it. And in this case, the system message is saying for tabular information, so anything that can be kind of presented in the table, return as an HTML table. So it's going to look really nice when some user goes in and says like, give me the list of all of the holiday, all of the holidays available in this company, right? And maybe we'll present this as a table. It says the date and what the holiday is. Do not return markdown format. So that's just a way to kind of get away from anything that will be hard for the user to interpret if it's not plain English. And if the question is not in English, right, this is also really great. Answer in the language used in the question. So, and again, driving and building applications, you want to make sure you get an understanding of your use case and your user. And let's say, since this is a company, if you're a global company, or even if you're not a global company, most companies, they operate in multiple languages or ask questions and or have people have different speak different multiple languages. So in this case, we're going to just make this a chat experience so that if you're not able, if you ask the question not in English, you also get back that response in the language that you ask, and not in English because maybe you don't speak English. And then we talk about each source here. So each source has a name followed by a column and the actual information. And then always include the source name for each fact you use in the response. So again, this is also saying if we're doing kind of some of the retrieval and providing citations or sources, this is giving the model that incentive or that guideline to say, okay, we need to make sure that we include this as a source. So a user goes in and says, hey, where did you get this information from? And we can also show that to the user again, which is really good for when you're doing information that isn't living in documents or something like that, because then we can show those sources there. And then this is kind of the last thing, and this is kind of more so in the code, but use the square brackets. So this is, again, the last kind of formatting. So we're going to say that we want to include this source and put that in square brackets, and this is more of a design choice than anything. The square brackets don't have any real significance here. Don't combine sources, so list them separately. So and we give it an example. So don't put like info1.txt and info2.pdf. And then we have these in these curly brackets, which are coming from the code itself. But basically that is pulling in any type of follow-up question prompts or injector prompts that we need. So that's the system message, right? That's just a system message to really design a high quality chat application. I think it starts with designing great system messages. So that's just the level of detail that it could go into it. It's not always required, but it's something to really focus on. The other one is also prompt templating, and that's prompt templates. And that's also really about enhancing the user experience. So if we looked at this code example that we had, we actually have a prompt templated within there. And it's basically giving the model a way to generate follow-up questions. So this is a good, especially if you're doing some sort of like educational or knowledge based product, if you will, because then you can make follow up questions to have the user, when they ask something, say like, oh, hey, are you interested in these other things about that topic? So for example, I could say, oh, if you ask something about large language models, then I could say the follow up questions the model could produce is like, are you interested in working with embeddings? Are you interested in working with retrieval augmented generation, or the Azure OpenAI service, or something like that. So in this prompt template, it's basically generating three very brief, so again, giving some more direction, follow-up questions that the user would likely ask, and enclose those questions in double angle brackets. So again, formatting is not a really important thing here, but we're trying to give the model some direction on what we'd like to see. Then we're going to give it examples of that. So this is from the last session, we talked about a bit about few shot learning and how many shots are appropriate. In this case, we're going to use 3 examples. In this use case, again, of this model answering the questions around health insurance, we're going to give it examples like, are there exclusions for prescriptions? What pharmacies can be ordered from? So maybe this is again for medication. And what is the limit for over-the-counter medication? So again, the model will be able to generate these follow-up questions, but we're going to give it some examples to give it exactly the type of questions we think a user might be interested in asking as a follow-up question. And again, if they click on it, if we want to design a user interface and they click on it, that basically asks the question, or maybe we can link to another source or something like that. But again, this is giving a better user experience, and from just doing a chat application and building something that you maybe want to enhance it a bit, other than just having a text box and letting the user kind of ask questions straightforward. So, and then we also have this last bit of guideline that might be really important. Again, since we want to make sure that this is making sense of the user. Yeah, it's like we don't repeat questions that have already been asked. So yeah, in this case, like, right, if I would ask what this, are there exclusions for prescriptions, I don't want the follow-up question to be also, are there exclusions for prescriptions, or something even similar to that. So that's another thing to kind of really, when you're building out these prompt templates, look at one, giving examples, so this few shot prompting, and also trying to provide some limitations on that information, right? We can put do not repeat questions, maybe whatever your use case or whatever the type of application you have, you could probably think of a way to phrase this. Model selection comes important as well. So there's probably, I guess, in the terms of what I've been building, and many West and many others, they're probably the 3 kind of dominant models that are out there at the moment. So before like, what, 2 weeks ago, 3 weeks ago, what please someone tell me where OpenAI Developer Day is. Give me the exact date, because time, like, for me, is like constantly Jade, like, I have no concept of time anymore. So please someone tell me exactly when OpenAI Developer Day was. But at OpenAI Developer Day, whatever that was, 3 weeks, 4 weeks ago, there was an announcement about GPT-4 Turbo. But before that, the kind of main model that we would be using for chat experiences was GPT 3.5 Turbo. And it's got some enhancements as well, in terms of training, I believe, as well, and tokens. That was last announced. But I think, again, from a chat experience, GPT 3.5 Turbo is certainly suitable, as well as the GPT-4 Turbo, which I actually personally haven't used. So I can't say the direct experiences of that, but I'm getting to it, and I think it's very exciting. It has a bigger context with which I make. But November 6th, okay. So that was, I don't know, not that long ago. Thank you, Sandham. But then the other model that's out there outside of the OpenAI world, Llama 2 also has a kind of design chat, or I think kind of fine-tuned chat model as well. And that's really important when you're looking with these type of models, because again, we want them to be able to respond quicker, I guess, from the Turbo, but also looking at the context window. And the context window is really about how much of a response that we can sort of produce, which could be important to your use case. So if you can see here, significantly GPT-3.5 only has 16,000 tokens, and a token could be a word, it could be parts of a word, but you can kind of think about it in that mental model. Where GPT-4 Turbo and with Vision has 128,000 tokens, so quite a big leap. Also, what's really cool, I usually point people when we're talking about formatting, which again, which you saw in the system message. There's also like a JSON mode, which is like a good structure when you're building applications, that because JSON is a good format to sort of read data from. And if you have a consistent format, it's much easier to integrate into an application. So that's another thing. So, maybe that's something, as we improve these models, the system message and all of those things that I just showed you might become less relevant. I wouldn't say irrelevant, but depending on the model that you choose as well. Cool. So that was chat applications. Let me know if you have any questions on that as well. And the question is GPT-4 Turbo available on Azure? And I believe I just saw the announcement like literally after this that it is at least available in the Azure OpenAI Studio. So yes, I'm gonna say yes, but yeah, do check. I haven't worked with it in my Azure environment, but I believe so. So yeah, great question. I should have prepared for that question. Cool. So we're going to look at a couple of things in search applications. There's a couple of concepts that I think I want to explain to you. Again, if you're really getting started with all of these, it's embeddings. Yeah. Thank you, Francesco. You've got it down. Only some regions are available. So embeddings, vector databases, chunkings, and then also kind of how to choose a model as well. So embeddings is a really talked about topic when we talk about search applications. And again, search applications could be anything where you're just kind of taking a user's query and trying to get some sort of answer or results on that. Oh wow, Princess, you really got it. Let me put this up there. You get the MVP award for today. So these are all of the regions that GPT-4 Turbo is available. And one day this will be outdated, but hopefully more expansion soon. So back to embedding. So at the beginning of this, you have some data, whether it's documents, that's kind of like the typical one, but also we're seeing a lot of tools out there like document loaders that are out there for different orchestration models. So or orchestration tools like LangChain or semantic kernel. And basically those tools allow you to kind of get this data in a good way to an embeddings model. So I've even seen one for like Gmail. So if you're really interested in building a search type of application and you want it to kind of go through all of your emails or something like that, not highly advisable at this moment, but if you wanted to, or if you want to do like a CSV file, text, things like that, HTML files, there's tons of these document loaders out there. I think there's one called, there's even like a Llama tool for that, such a thing. But that is where you can find ways to get this data in a good format. But then you also have the other element, which is like the user interface or the application, whether that's a search, whether that's something that you've designed. But essentially, they all are going to take that data, the query from the user, and the data that you've loaded, and that's going to feed into an embeddings model. This embeddings model will then create embeddings. And embeddings, you can think of it, it's really hard to think in this concept, but it's basically assigning a point in space for that query, whether it's a sentence, a word, a string, or an email, whatever. It's basically assigning a numerical value that sits in space. And then we need to actually store all of those values in a good way to be able to retrieve them. And one of the things we found is if you build these things called vector databases, it makes that when we need to pull them out of that space much easier, or at least more efficient. So there's like two, like any database, there's two avenues. There's the read and there's write. But and with vector databases, when we look at different models that are different databases out there, there's ways to sort of think about those in that space. But to give this like some more context of actually how this would work. So let's say we have this application that takes YouTube transcripts. So let's say we want a user to be able to search on something and then essentially say, okay, I want to find all of the demos about embedding models, and we have gotten all of these things, all of the transcripts, and we use maybe a tool to do that, and then we take those, take that data, we create get an embeddings model that actually going to create the embeddings from the text. So then now we have all of the text in a numerical type of value, and we store that into a vector database. Now our user comes in and says, I'm looking for demos about embedding models. So we can't just like search this in plain text. We can't search a vector database just, okay, well, write a query that just says I'm looking for demos. So we also use the embeddings model to create embeddings from that search. And then essentially what we do is then find out where there's any similarities in those embeddings. And in this case, I put this little circle around it, but then we're pulling in the transcripts that are similar or mentioning some sort of embedding model. Now, there's certain things that you need to understand about how these, how we can make this circle, right? Because some models, they plot these yellow dots, which are all of the, let's say, all the embeddings, but all of the transcripts or the parts of the transcripts. And we'll talk about chunking later on, in space. And they have a decision. They make a decision essentially through the embeddings model of what sort of similarity or where should we place them in space. Depending on the model, some things might be closer than others. It's not, and again, the type of results that you will get from your search will vary widely depending on the embeddings model that you choose. So I know there's a lot of focus on vector databases and choosing those things, which is important. But there's also should be very much a focus on the type of embeddings model that you select, because that could vary again about how big the circle is and what's included in the circle. And the circle is basically the results that you'll be showing to the user. So it's very important to both explore and compare embeddings models. Let's see, we got some questions. Do you know a way to return the total tokens used in completions request? I'm requesting Azure OpenAI service with my Azure Search connected, but it's not returning the tokens in JSON result. Thank you, Renato, for that question. That's interesting. Normally at the top of the request, there's total tokens. I'd have to look at the documentation again. Maybe there's something changed, but normally there's a good way to see that. But yeah, I'll take a look at the docs. Maybe if you can find me on any of the socials to find the answer there. But normally there's you can get a token count on that. But even if I would also check out in the playground, maybe you can pull that out. But it's a good question, because knowing the amount of tokens you're using is a very important thing when we are talking about the limitations of these certain models. The embeddings are the vector. The embeddings are the vectors themselves. Yeah. So I mean, the embeddings basically. So these embeddings here are the vectors. I'm trying to move my model here, but so this is like a vector here, and that's storing all the vectors into this database. So that's kind of how it works. And again, when we want to pull them out, we need to find them in the space as well. Cool. So one of the things is if you're choosing an embedding model can be difficult or easy. So I put some links here, and I'll put them in the resources as well. But OpenAI has their own embeddings model. And that's probably, I think, from my perspective, the only one I've been using primarily. But there are also very much open source embeddings models out there. So if you go to Hugging Face, there's a category just called embeddings, which I thought I could pull up, but now I've lost my presentation. But essentially those models, you'll see like what they've been specialized on. So an example of that is the sentence transformer. So that model itself, also that embeddings model, specializes in embedding sentences. But there's also ones that are specialized in embedding code, for example. or even different types of text or different types of languages. There was one I think I saw that was like just designed for like a research text. So do explore that. There's another session that I'll probably link to as well, where we kind of looked at how to compare them. But essentially, there's different methods like using like cosine similarity to see how these models kind of find what is similar or how they compare. And you would be surprised again about how different these models could be or how differently the models can see the world. So yeah, I mean, I think the default or the go-to to go on the shelf is the OpenAI one. But then again, maybe for your use case, you might explore different other ones just to see how they compare as well. But I think you choosing an embedding model is probably a critical step for building a good search application. Choosing a vector databases, so they're also quite a lot, and I think that's to me at least. And you can find me on the internet if you disagree. I think choosing a vector database, especially for most use cases, is secondary to the embeddings model. But that could be vary because of cost or size or whatever you have. So I'll put a caveat there just to protect myself. But just to show you the ones that are out there a lot. So this is actually coming from the semantic kernel documentation. So a lot of these tools also have connectors to make it like really easy to store them once you have the document loaded or an embeddings created. Um, so one of them, so Azure has like basically three offerings now: Cosmos DB, Cognitive Search, which I think was mentioned, maybe Renato, Postgres. But then there's also a few open source and even uh, other ones out there like Weaviate. That's a pretty big one. Pinecone I've used before. And again, they all have some differences. I have this like benchmark site here, and to be honest, it's like benchmarking in anything in generative AI and LLM is kind of like your miles may vary. I think this is a good resource to look at. Essentially, it has some differences between of them, and like I said, they all handle reading and writing and storing a little bit differently. It's probably in the weeds for most people, or a little bit in depth if it's your first time building an search application. You can actually also, especially when I started out, even do in memory vector storing, so you don't even have to use a database. Again, this is just like you wouldn't want to do that for like a production application, but if you're just testing out, there's a few libraries in Python that you can do that with, and that also saves a lot of time. Cool. Is this also a critical step in building chat applications, leveraging your own data and provide responses? Yeah. So, yeah, a couple of things. So, I mean, yeah, the one step is obviously the system message and building that out. But then, obviously being able for the model to produce or get any results. This is also pretty critical. Is choosing the embeddings model because, like I said, this will vary, and it's worth testing out, but vary in terms of the embeddings models that you use, and also if you use different tools, so like document loaders and things like that with LangChain and semantic kernel. So I won't say everything's a critical step, but these are probably two important ones, especially when you're talking about leveraging your own data, because like we said in the system message before, when the model can't find an answer, what does it do? It says, oh, I can't find the answer, or I don't know, right? So if you're getting a lot of I don't knows in your application, and you know for a fact that that model or that data should be available to the model to retrieve, it's probably worth looking at exploring whether your embeddings model, how that's sort of being operating or handling. But yeah, I think that's pretty good point. Thanks, Francesco. Cool. Now we're gonna go back. So the other one is chunking. The last bit I want to cover, because I want to keep this kind of 45 minutes here, and I'll take any questions after as well. Is the chunking strategy. So if we go back to this like diagram that I showed, right? So getting this data into the embeddings model or feeding this to the embedding model is process I think very technically called chunking. I like it because I used to have a friend called that would say like, oh, we're gonna chunk this somewhere or chunk that, and more like casually. But this whole process of getting that to the model, and particularly how do we break these YouTube transcripts up, is an important question, right? To the point, one of the ways I've seen embedding this model, like a model being specialized, is a model that specializes in basically chat or like script type scenarios. So it can identify speakers, and that might be really important when we are querying or making a call to the vector database, because maybe that's going to be important to our YouTube transcripts, right? Maybe we only want to find out when I'm speaking or something like that. And chunking this in a good way to get to the embeddings model to find that and understanding that is another probably again important step in here on building out this stuff. So there's kind of two strategies or two main strategies, I guess, on this approach. So fixed size chunking and like content aware chunking. So fixed size chunking, people might still say this is like the naive approach. It's probably the easiest approach to chunking, and essentially it's basically saying, and we can define this in code, whatever language you choose. We want the chunk size to be a certain byte count or a certain size, and that's going to be applied kind of throughout the document. Um, there's a good use cases for this, whether it's like data that's just typically unstructured anyways. One of the examples I've seen is like log files. So like you have a system log or something, and you know how it's just like gibberish and anyways. Maybe just fixed sizing this instead of trying to get a chunking strategy that makes the best sense. It could be a good way to do that. Also, fixed size chunking, very efficient. And if you want to, start with that, and see your results, I think that is another suitable use case. But where it obviously falls apart is in the context. So, in this is just lorem ipsum text, so there's no way I can like give you good examples. But as you can see here, it's breaking paragraphs apart, which could be breaking even sentences apart or words apart, which is probably never good if we were trying to find specifics. Or again, like you can imagine if you take a transcript like of this and all of a sudden you just break in the middle of my sentence into a whole new chunk essentially. It might not, and then they're in different spaces of the database. It's going to be really hard to find value from that. But in other cases where it might not be as important, fixed size chunking is certainly suitable for that. But then we also have this context aware strategies that are out there. So the first one is called recursive chunking, and I think it's kind of like advanced fixed size chunking. Fixed size chunking. Well, basically, we give this a designated chunk size. So in this case, 256. And then we basically say, go ahead and split the text, all the text that we have. And then, chop it up. And if it's not 256, then just keep kind of chopping up again, or going back recursively until we can fit that chunk size. So in this case, we probably have some more strategy around that particular chunk size, 256. And then, but the chopping back we might still lose some context that we might really want. So it's still context aware, or we're kind of driving that chunking strategy. But again, we still might lose some things like that. And I like to look at it like very much, this chopping method here. We're getting these fine cuts, but we're not necessarily blindfolded. But we're kind of, again, we don't necessarily know, again, with the recursion, where those cuts are going to be made to get again to fit the 256. Cool. So let's see. We got a good question here, which I love when we get these type of questions. I have a 200,000 word worth pages to analyze. How much would it cost, and how much time would it take to convert this into embeddings, or is there a cheaper option? Wow, that's a lot to answer here. So in terms of like the actual pages, so one of the things that you need to realize, length is a very good indicator in the type of trunking strategy that you have, but also the content as well. So not knowing exactly what those 200,000 worth pages are, I can't really designate and tell you exactly what the strategy will be. And then the cost, I don't know. Again, it depends on what you're choosing for storing this, whether it's Azure, whether it's Pinecone, Weaviate. I do think most of them have good free tiers, so it's worth looking at. And then you definitely need to convert this into embedding. So there's there's probably no good way to, especially with all of those documents. So yeah, I definitely look at the different options out there, and then also to the point of the content. One of the things I'll talk about just now, which is a good segue, is like not only is it like making content aware, but like the type of content that you are working with. So one of the content awareness strategies is like actual context. Um, so in this case, and maybe your 200,000 word pages is like research articles. So instead, we can make this chunk chunk strategy where that we hold the context for each chunk. So in this case, what you see here is I have this chunk 1, chunk 2, chunk 3, chunk 4, but what you'll see is actually it's pulling in not only that paragraph, but also the header or the section of that research. So we know, or the model gets to know better context here, that sequence classification task or token classification task or sequence generation task are all focused on fine tuning BART. If we didn't have those things, maybe this could still make sense, but giving this sort of context aware chunking, and again, these are all strategies that you'll see in different orchestration tools and different things that are available out there when you want to actually implement these things. It gives it a little bit more sense. So then this is probably, again, if we wanted to say, oh, hey, I know in my document we have these things like 3.3, 3.2, the structure that way. Building a chunking strategy that's like that will produce a lot better results than doing fixed a fixed rate or even recursion, because you still might miss those things. The other one's examples, and this is some code examples as well. We can do context-aware chunking on Markdown. So like, for instance, LangChain has a Markdown text splitter. So, Markdown has all the indications, symbols and things like that. So like your, hash for H2s or links or, things like that. So we can actually split the text in that based on those things and give it a little bit more context awareness. So this is using the Markdown splitter built into LangChain, and I think other tools that are similar to LangChain have these capabilities. But that's just to give you a kind of real code example, and you're free to sort of explore that. The other one, the other one is also there's even code splitters. So I've seen, I think also in LangChain, if you have like a JavaScript file that you want to store in a database, we can do JavaScript or code splitting of that. And it gives it also even more context awareness. So, maybe we want to split on functions, for example, and not just random lines of code, or split on comments of the code. And that's really, again, if you want to drive some of the maybe even like GitHub Copilot type of experience or something. That's again, some of the technology behind it is how to split that content better. Cool. Perfect. So that's going to be a wrap for today's workshop. Like I said, then there's a link that was shared earlier, and I can kind of get that in the chat. We do have another session next week, very similar to this, but we're going to be looking at AI agents, functions, and as I promised, image generation applications. So do tune into that. Oh, and thank you, Erica. Wow, you're on fire today. We have one question, so I'll wrap with that. How does LLMs provide context awareness spread over the document while extracting chunk data looks easy with NLPs and RE? So I mean, with these text loaders and these tools out there, that's essentially what we're doing. Is kind of we can use an LLM and provide that level of context. So, like, for instance, the Markdown splitter has some context around Markdown. You can still also use things like NLPs and RE as well. These are all good tools to use in terms of splitting that. But great question, Kantaresh, and definitely worth exploring more. All right, perfect. So now we're at the 50-minute marker. I said 45 minutes, but I've missed that. So do check out next session if you like this one. I'm going to go ahead and put in the links. Do check out the links as well. The resources I shared today will be there. But thanks again. You spent 50 minutes with me on the internet. You could have been anywhere on the internet, but you spent it with me. So that I truly appreciate. Hope to see you all in the Discord, and we can continue the conversation. Thanks, and have a good one, everyone. Bye.